Welcome everybody. I would like to introduce Stan Pekinhu, who is telling us about managing internal public key encryption keys at scale with Anchor, and why revoking access is so hard. Can we have a round of applause?
Thank you. So this talk is going to be about PKI systems, something we looked at while I worked at HP with basically HP Cloud deployments. And mainly about why the revocation is an issue if you're doing internal PKI or any kind of PKI, any kind of encryption of data on the fly between services. It's not that much different from what happens in public, but still a bit of a different thing. So I worked with HP Public Cloud from the beginning until it finished late last year. Did some internet telephony work and basic software all-time traffic processing. Embedded programming, now I'm doing mostly security consulting. So basically, I'm the SRE DevOps Sec. And I'll keep adding to that, hopefully. So what happens if the stock image businessman in a black hood steals your keys? Basically, that was one of the questions about the internal system. So this is serious because you probably know why you want the encryption on public websites. Basically, you want to make sure that you're talking to the right service, you're talking to the right company, you're sending only encrypted data, and potentially also the verification goes the other way. Maybe you're using client certificates, maybe not. But if something happens to the private key of the service, basically the person who has them, they can spoof the connection, they can pretend they're the service you want to talk to, they can basically tunnel your data, steal it. It's a problem. So this presentation is going to talk a bit about the public revocation and private one. They are similar, but there are still differences. For the project we created, the context was private. So what happens if someone steals your keys is, hopefully you noticed that. And in most cases, that's probably going to take either until you notice it from the logs or your internal IDEA systems, or until it starts being used somewhere and basically you get notified that someone is trying to pretend to be you. Realistically, that's probably not going to take shorter than a day, unless you've got it completely automated. If you need to be notified, it's going to take a good amount of time. So at that point, you probably want to revoke your key because you don't want anyone else to be able to use it. So your options are CRL, which is basically a system that advertises in the certificate, OK, here is the endpoint where you can update the list of revoked certificates, and you should do that periodically. OK. This has problems with a lot of things we'll see later, but mostly with basically size of updates and periodic updates. You don't want to do it all the time. It's got problems with, OK, what happens if the endpoint is not available, et cetera, et cetera. So browsers implement something similar, but they call it CRL Set. That was started by Chrome, I believe, where they ship the whole CRL with the browser and do the updates. OK, these are the active stuff you have to do something. Another active thing, but on the connection itself, is OCSP. Basically, at the moment when you connect to the service, you get the certificate which says you can verify my revocation status at that endpoint right now. So you query that service, and it says it's valid or it's not. Good. but not awesome, because what happens if that service goes away or you cannot contact it? So we've got OCS stapling. That means the response that you would get from OCSP is stapled into the SSL handshake itself. So while you connect to the service, it basically responds with something like, so as far as I know, 2 minutes ago I was valid, and that's the response you would get from OCSP server, and it's signed, so you can trust that I'm not making it up. And finally, if everything else fails or you cannot revoke the certificate, it's expiration. Basically, at some point, it's going to go out of date. With our current public certificates, it's usually months or years. And that's assuming you actually know you had a break-in again. So just on OCS stapling, it actually doesn't require you to talk to any other services, which is probably the best evolution so far we've got on the on revocation check. It allows you to basically see from the traffic itself whether you're in a good position or not. OK, in practice, there are loads of problems with all of those systems, one way or another. A lot of them fail open, so if you're using CRL Set, or OCSP, in the default settings as they were originally created, you basically need to connect somewhere to know whether the certificate is valid. If you can't connect there, you have to assume something, and usually it's assuming that everything's all right, which is awesome. Still the key. Run the Mirai botnet, spam that endpoint. No one can access it. Awesome. With the stapled OCSP, it depends. So right now, we don't have the, at least in most popular browsers, I believe we still fail open, but there's a must staple extension coming in, and it's getting more popular now, where you can say in your certificate, this is going to be used in the environment where OCS stapling is enabled, and if it doesn't happen, assume something's wrong, because we're going to use it that way. So awesome. You don't have to assume you fail open. Finally, with expiry, if it expired, it's not valid. There's not much more to it. As long as your time is right, it's going to be fine. So also problem with quick updates for CRL and CRL sets. Not only it's not real time, you probably don't want to update those lists before every single connection. It's just going to take a long time before you actually get the response back. And they're only going to get published after the provider actually updated, well, got your request for revocation and processed it. OCSP, real time, great. Expiry, kind of, that doesn't matter. It's passive. So can public use it? It depends. If you've got a cheap or free certificates, have you paid for revocation? Because sometimes it will be requested. In CRL sets, not all the certificates will be included there. It's basically a select. It's basically a selected set of CRLs, or even subsets of them that will be published. So EV certificates, intermediates, big CAs, if they're compromised, yes. You on your shopping website, not really. OCSP, of course, real time, everyone's included, yes. Stapled, yes. Expiry, passive. So what's the problem with OCSP then? So far, it's been great real-time access. Everyone can do it. Well, every time you send a request, you announce to someone else, hey, I'm connected to this website. Probably not what you want to do. And at scale in public, issues like heartbeat show that at some point we want to revoke sometimes millions of certificates. And that is not going to go well with CRLs. There's been a big spike, but likely we haven't revoked a tiny bit of all of the certificates that were potentially affected by that leak. Yeah, no CSP good, expiry, passive, everything works. So in public, CRLs basically were dropped from Firefox in 2013 or slightly before, because, well, it's a very limited list. OCSP won't be used unless it's an EV certificate. Just doesn't matter. It provides way too much issue with privacy, and EVs are going to be covered by CRL sets, hopefully. So we're relying only on stapling right now, and hopefully that works. So that's the public part, but let's say you're deploying service internally and you want to protect your endpoints between web services, databases, queues, etc., etc. Right now we're deploying services on environments that are very dynamic. The IPs change a lot. We're doing software-defined networking. Hopefully everything works great, but if you suddenly cross your paths with another network or another service, or someone has access to your affect your routing in some way, do you know every time where you're connected to? If you connect to another database that gives you good data, are you going to question whether that's your service or not? Is the database going to question whether the client has only the right credentials or the right network, or is it going to verify anything else? So especially with dynamic networks, the hosts come in and out. Maybe you're using public IPs and someone, well, your instance goes away, someone reuses your IP, you're going to connect them there again before you can refresh your architecture config. And is it even your server at the moment? How can you verify it? So, straw poll. In your libraries or services, have you ever specified a CRL path when you're trying to connect to a service? Yeah. Do you know if your library supports OCSP at all? Probably doesn't. Most of them don't. If you're using standard connection via Python, Node.js, Ruby, anything, nope. You have to implement it yourself or use a library that specifically allows it. And if you're using internal certificates, do you have a plan of how to revoke them and what to do if the keys go missing? Hopefully you do. So, yeah, even if those mechanisms work, there's virtually no CSP support, so you have to implement it specifically. CRLs need external updates, so you have to do it periodically and distribute it everywhere. So if you miss an endpoint, it's not updated. And CRL sets don't apply because it's your internal stuff. They're not, revocation for them is not going to be published on CRL sets because they're not deemed worthy. So that was the whole motivation part for what we did in HP Cloud. And the new idea is expire your certificates early, expire them often, and remove all of the long-term, we request a certificate for that service, send it to the team that does PKI, they process the request, maybe they approve it, maybe they have questions, and they return you the certificate that you then use. Well, let's remove all of that. Let's just do it in an automated way, because robots. So the people that usually clicked accept on the certificates in private services, they had some rules about what to allow, what not to allow. So if we're removing them, that has to be automated as well. And let's add as much authentication as we can, so multi-factor server authentication, authorization, actually. But what's multi-factor authorization for servers? So we know it for people. This is something you know, something you have, something you are. And OK, we can deal with that. Hopefully, everyone's already using two-factor authentication on their services. How to do it for servers? OK, so we have credentials are suddenly something we have because they're in a file somewhere. OK, they can be stolen, so we can do better. Something the servers are, so basically, they were given IP by another piece of infrastructure, and they cannot change it because hopefully they're completely restricted only to that IP. They cannot spoof their addresses. They cannot see other traffic. So that's another factor. Something you know is something that you can probably create in your environment if you're running your own, or do it via specific APIs on cloud providers, where you can have a dedicated channel of communication. If you've got your own infrastructure, you can, for example, have a shared block device which hosts writes on. Basically, am I talking to that server infrastructure? Tell me if I'm talking to that server. It should respond with that string if it's correct. And the infrastructure, for example, does it via the host where the service lives. It communicates with the host. Host communicates via, let's say, KVM, via shared block device, puts a specific file there. Service then can read it and say, hey, you wanted me to say back to you something, and I'm saying it. So it helps if the system is compromised, but not 100%. So you can steal the credentials. You still have network. You can successfully spoof the service because the networking was misconfigured. You don't have the credentials, or you cannot confirm something else. Hopefully, at some point, you caught the problem. So the implementation. Basically, we went for an extremely simplified CA, which is called Anchor. It's now part of, well, from the beginning, it's been part of the OpenStack security. It's used, I know of some companies that use it internally. Don't know if I can say which ones. But it's in use. It's extremely simplified, which means there are great pieces of software out there, like let's say DocTag. Okay, it's got great infrastructure. It's got agents to automate some stuff. It pretty much does all the PKI stuff as needed, but it's kind of big and complex beast. So let's do something simpler. We only want to get back certificate because we need it. That's all we need from it. And with complex projects like DocTag, not that I'm picking on it, but they're basically very stateful services. Pretty much every PKI implementation that you're going to look at right now will require you to send a request for a certificate, get back an ID to check back later, and then retrieve your certificate after some time when it's approved, or basic query for the state. We don't need that or want that. It's basically a new flow. So stateless, because it gives you easy clustering. You can just set up multiple services. Great. We went for pluggable components because OpenStack itself is basically made out of components that you can easily swap in and out. It's very configurable. So following that tradition, we've got pluggable authentication, validation, requests, modifications, and signing backend. What does that mean in practice is you can, for example, have the LDAP backend and check the password there. Or it can be local file, or it can be Keystone on the authentication server, or it can be something else. Is the certificate. Okay, so we're going to do request validation. Are we requesting a certificate for a specific service? Is it in our domain? Is it what we're expecting to grant, et cetera, standard validation? But also, is the request coming from our network, and is it coming from the range that is supposed to host that service? So, a bit of defense in depth. And finally, modify the request. Let's say something is sending very basic request for just a domain name in common name. Well, it's bad, but let's fix that. We can add, for example, subject's old name. We can change what service is requested. So either it's going to be a server certificate or key signing or client certificate. Adding any extension is possible. And signing backend. So we can sign it locally with basically OpenSSL. We can sign it with PKI 11, so any kind of hardware security modules, any kind of keyrings, local hardware. I can plug the GNOME keyring into the service, and it still works. And I went for safe Expiry of 9. There's been enough issues with ASN1 as it is. So we've had issues in, it's basically a notoriously broken implementation. We've had issues in OpenSSL, we had issues in kernel, we had issues in pretty much every single library that implements it. So let's not, it may be still broken, it can't be perfect code, but at least the whole service is implemented in Python, so all the parsing, serialization, deserialization is implemented in pure Python. The only part that, of Anchor which works in native code is the signing, because basically you do not want to re-implement that. That's one thing, and another one is you want to do it probably at scale in external services. So HSMs, hardware key stores, that's a much better option. Okay, so what are simple certificates then? We're basically going stateless, so we cannot have proper serial numbers, as in they cannot be sequential. We're just generating a UUID and putting that in the serial field. It's awesome because that's the whole UUID is 128 bits. There's a bit less if you keep to the standard, but if you generate that actually randomly, it's not going to collide. So you can set up 3 Anchor servers, load balance between them. It doesn't matter. No policy extension because, well, no one's going to look at that. It's for services to talk to other services mainly, and we don't need it. Minimal extensions, usually SUN and the usage bits, because that's what we need. There could be something more if you need it. There's support for it, but in general, only if the services actually require it. So simplified requests. It's stateless. You get only one request API. You say which registration authority do you want to sign it. So one registration authority can be basically configured for different set of services than a different one. One can be authorizing against LDAP, another one against Keystone, another one against plain text files. What you want. And immediate results. So basically, That is our client library. You send your credentials, you send the registration authority name that you want to sign your request, you've got user password, CSR. You get back the certificate. That's all good. So if you actually want to deploy it in the system, you can't really do that with public CA, unless you've got your own public intermediate, then great. That's the way for you. But usually you will want your own internal CA that all the machines in your data center or deployment environment trust. You can use the, well, you should use the intermediate to actually sign your certificates. So that's the typical parts of PKI. But now, periodic refresh. Usually, when you deploy certificates, it's probably you deploy it and then deploy monitoring for when it needs to be updated. Basically, someone has to go and do it. That doesn't work in this model. It needs to happen automatically, and it needs to happen very often. So there's an awesome piece of software called Certmonger, which will do which is basically exactly for this purpose. It will monitor your certificates. It will use a plugin where you can put the curl command and basically make it talk to Anchor, so all the certificates are refreshed when they're needed. Or just stick it in cron. Of course, with the right monitoring, because if it fails, that's a bit more dangerous than your certificates getting, that your usual certificates getting 1 month to the expiry date. Yeah, this one goes away right now. And the services need to be actually able to reload the certificates, which is a problem. For now, pretty much every service out there which natively takes the certificate will have problem reloading it without affecting the traffic. So if you, for example, use something like MySQL with SSL communication, you have to restart it to load a new one. If you're using Nginx, you have to poke it to reload the certificate, and it will, if I remember correctly, it will stop accepting the new connections until the current ones are handled, reload the certificates, exchange the socket, and then accept the new connections. So no outage as such, but delay. So usually it's rather gonna look something like that. So SSL proxy will come in front of your service, and stunnel, for example, has great support for reloading certificates. You can poke it, it will still handle your traffic while exchanging the certificate you use. And that frees up your service from ever knowing that it happens. It also allows you to basically put SSL in front of services that don't even know about SSL, or services that are weird, and like RabbitMQ, I believe, actually sends different protocol handshake if it thinks you're talking SSL. So using RabbitMQ, you can't easily send encrypted traffic to a SSL proxy and then to a service. You have to send it to a proxy which will pack it in TLS, send it to another proxy which will unpack it, send it to the server. The good part is you can do that to services that don't even know about SSL. So if you've got some custom project that needs to be on the network and uses just standard deployment, standard HTTP or whatever other protocol, just tunnel it. So with service reload, yeah, a tunnel is one that we found works pretty good. There's another one that I can't remember right now, but basically 2 of them handle it. Other services have some kind of issues with reload, so if you're doing that, at least be aware what the issues are. Maybe it's all right if you stop processing some traffic for a second or half a second, but just be aware. So, OK. We basically changed the whole architecture of how we're doing SSL, and what did we get back for that? So awesome thing is that the referral of certificates becomes a normal event. It happens every day. When I said short-lived certificates, I meant you grant them for 24 hours or 12 hours or whatever you can handle. Basically, as long as you can react to failures during that time, make it that short. Because expiry is automatic. So if you don't get a new certificate, it goes away. If someone steals your key, before you know that it happens, the certificate is going to be expired, because it expires the same day. If you have some services that are created maybe for test, maybe you are using them, but they go away because people don't need them anymore, stop experimenting with that. Maybe there's a new version that that is deployed in a different way. You don't have that. You don't have the need for the certificate you already granted. In usual deployment, unless you track all your certificates very rigorously, some of them will just go missing. Well, you'll still have the certificate that's valid for some service and could be potentially used for tricking someone into believing that your domain is serving something, but you don't care about that certificate anymore. It's not attached to your service, so you probably didn't even revoke it. In this model, it goes away automatically. So you stopped using some service, you stopped the CA servers from running, it goes away the next day. You don't need to do anything extra about it. And less human involvement. So you need to make sure that someone can handle incidents for this, but you don't need someone to monitor a queue of requests for certificates from different teams and basically say they can have this certificate, they can't. And not the main goal, but this also a nice thing that because you've got the log of all the certificates that were granted, you know who they were granted to, you know how they authenticated, you know which domain names they were granted for, you automatically have more input into your CMDB. So you know which services are still live. CMDB are often only semi-automatic, so some of the stuff will report that it's running and it will report its attributes. Some of that will be filled out by teams because they know that it's part of service blah and now it's marked as such. With this one, you've got a log of certificates granted. You know when it came online. You know that this service is running. You know when it stopped running. You know how many domains it's handling, etc., etc. So useful things. And yeah, like we basically came a long way from a pre-packaged new version of a website that gets deployed on the server when the new version is ready to led to continuous deployment the whole day, and it's a normal thing now. So exactly the same model for ephemeral PKI. We don't care about those big versions and very strict management anymore. It just happens, and it's great. It's new normal. Issues, there are some. So your PKI was a critical part of your infrastructure before, but it's not critical daily. As in, certificates don't, if you grant certificates for a year or two, they don't disappear suddenly. These ones do. So how long you want your certificate to be valid is probably depending on your incident response time. If you have a team that's 24 hours available, great. If not, you may want to grant them for 2 days, because if your networking goes down, gets misconfigured, or the service goes down for some reason, you can't connect to the service anymore. You trusted only that certificate, and now it's expired. And yeah, not all software deals with the refresh that well. It's getting better, but we're not there yet. So that was one of the things we did because, well, we had a very dynamic infrastructure in HP Cloud. We needed to provision new hosts for virtualization. We needed to make sure that with all the software-defined networking on top, it actually is reliable. We're talking to the hosts we think we're talking to. And if hosts go in and out of the systems, we can handle it quickly without engaging people. So automation, great. But just shout out, there's also a couple of other cool things that came out of the HP Cloud security project. So if you're interested, have a look at code security scanning, which was Bandit and Gas. We wrote Killick, which is basically a helper for CA. If you still want to grant your certificates automatically, it uses the same core as Anchor, but instead of approving them automatically, it will run all the checks and email you about it. Then you can do the standard thing. That's still proof of concept level. And Recon, if you're familiar with Linux for system hardening checks, that's another great project. It's got a different approach where it can actually go deeper into the configuration, where Linux is only bash-based, unfortunately, well, shell-based. We're actually parsing configuration as it should be parsed and dealing with elements as they exist in the configuration. There's no approximation based on grep. So shout out to people that worked on both Anchor and those projects, that Robert Clark, Doug Chivers, Tim Kelsey, Grant Murphy, and Travis McPeak. They're part of all of those. Thank you. And so any questions?
Do you have some examples of software that didn't handle? Do you have some examples of software that didn't handle frequent updates of certificates?
Sorry, didn't quite catch that.
You mentioned before in an earlier slide that some software had problems with frequent updates of certificates. I was wondering if you could give some examples.
So everything that's not a web server. Well, actually, that's true. Pretty much every piece of software like database, MySQL definitely did that. I think Postgres also has problem with that. RabbitMQ definitely. They can't handle rapid changes, as in you cannot tell them to reload the certificate for the new incoming connection while still doing what they're doing right now. They need to either do a complete restart, or they need to break all the connections and disable the socket and bring it up again. Or basically, transparent change is not what they were expecting to do, so it's not implemented. And it's actually, once the software is written, it's kind of hard to shoehorn it in later on. That's why sometimes it's easier to just do it with a stunnel in front of it rather than service itself. But it's not that they cannot exchange certificates quickly. It's just you need to plan how they do it.
How long before expiry do you start trying to get a new certificate?
So that's up to you, really. Well, it's the thing about how quickly can you respond to problems. What we did was 48 hours certificates and refresh after 24. So you get another day in case something goes wrong. But definitely don't do it at the last possible moment.
Okay, do we have any more questions? Yep.
What's CMDB?
Content management. Configuration management. Sorry. So basically, your not source of truth, but basically your database of what are you running in your system, what's the hardware, what are the services, what are the users, anything about your services. That's the source of information that you can reach to.
Thanks for the talk, very interesting. You said that Anchor requires a CA, an internal CA. Does that mean we still need to run dog tag with it?
Oh no, it requires CA as in CA certificate. So basically, you need some kind of, you need one certificate that's the root of trust. And either you basically distribute that public component to all of the servers so they know that anything granted from that CA is to be trusted. But usually what you do in deployment, what you would normally do is basically have that certificate stored somewhere offline and intermediates created from that. So for example, each actual service granting server certificates would have their own intermediate.
What's the URL for the Anchor project? And is the Anchor project useful if you're not running OpenStack? Is it able to run it by itself?
Yes, it's very much independent of OpenStack, as in it comes under the OpenStack umbrella project, like all of those projects that I mentioned, but you can run it completely independently. You can find it at github.com/openstack/anchor.
Is there any support for logging certificate issuance to certificate transparency logs?
No.
How easy would it be to add that? Is there a plugin interface for just invoking arbitrary plugins upon the certificate issuance occurrence on the server?
Yes, so basically there are two modes right now. You can log it either locally or log it to the CADF audit system. So CADF it's supposed to be a set of standard ways of logging and auditing stuff that happens in private and public clouds. Anchor currently can send CADF events, so that's useful for auditing, but replace it with anything else and yeah, you can log to CT. And we should probably talk about that later.
Okay, we've probably got time for one more question, if there's anyone who's got a burning question. Okay, Fraser again.
Where does the Certmonger renewal helper script live, and can we absorb that in Certmonger itself to make it easy for anyone to just deploy Anchor and use it with Certmonger on the clients to automate the renewal?
So there is the plugin somewhere in the Anchor repository. I think it's under tools. If you look for it, it's going to be there, I believe. Whether it can be integrated, I can't remember right now. There was a reason we wrote a plugin. I don't know if it was because it's just faster or because it runs in some different way. I think there's a mismatch. One thing that came into that was that Certmonger expects service to act in the same way as traditional CAs right now, where you first send a request, then query for status, then receive the response. And that if you expect to do exactly that, that just breaks down because you need to do it in one go. We're doing only one request, one answer, that's it. Yeah. If basically we went for complete statelessness and load balancing, so we don't guarantee, well, we don't expect you to guarantee that the requests go to the same Anchor servers all the time.
Okay, can I get a round of applause for Stan and his excellent talk?